I've been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This is the video for Algebra Unit 8, Lesson 2. We're going to be looking at more features of quadratic functions, specifically solutions, vertex, and the axis of symmetry. A solution to a quadratic function is also called the zero of the function, which is the x value when y equals 0, which we know as the x-intercept. So you will hear all of those used interchangeably. That is solution, 0, and x-intercept. And you may also hear it called a root or roots. So you need to know that those words are interchangeable when we're talking about quadratic functions. And you know what x-intercept is, so we're just going to be applying it to a different type of function. So a quadratic function may have one, two, or no solutions. So let's look at examples of those. If it has one solution, that means it has one x-intercept, then that's going to look something like this, where you have the quadratic, it touches the x-axis only once, which means that is actually the vertex, which we already talked about. So if the vertex is on the x-axis, then that means it's going to only have one solution. So this is one solution. If it has two solutions, that means it has to cross the x-axis twice, for example, in those two places. And so the quadratic may look something like this. Again, this is two solutions because the quadratic crosses the x-axis twice. And the last example is when there is no solution, which means the quadratic never crosses the x-axis. So something like that, or it could also be something like this. So it never crosses the x-axis. This is no solution. There are no x-intercepts. The axis of symmetry is the vertical line that divides the parabola into two symmetrical halves. The axis of symmetry will always pass through the vertex. We've already talked about the vertex, but we're going to talk about it some more. So remember, a vertical line is straight up and down, and the axis of symmetry goes through the vertex. So the axis of symmetry on this example would be this vertical line. And we should know how to write the equation of that. It has an undefined slope, and the equation would be x equals 2. So the axis of symmetry there would be x equals 2. I strongly recommend that you actually draw this graph in your notes. If necessary, you can take a screenshot maybe, but you really need to have this graph in your notes so you know what I'm talking about. And I don't mean a sketch without graph paper. Do it on graph paper. It's going to be more helpful. So again, the axis of symmetry goes through the vertex. So it splits the parabola into two symmetrical halves. In other words, if I fold the paper on that axis of symmetry, the parabola would line up on top of each other. So over here, my axis of symmetry again goes through the vertex. And so my axis of symmetry in this example would be x equals 4. So your axis of symmetry should always have an equation of x equals the x-intercept of that line because it's an undefined slope. You'll notice that the axis of symmetry in this first example, example A, the axis of symmetry is exactly halfway between the x-intercepts. So when there are two solutions like there are in example A, this is 1, 2 away, and then this is 1, 2 away. So the axis of symmetry is right in between the two x-intercepts. In example B, there's only one solution, so the axis of symmetry goes straight through the solution. So you can kind of use the solutions maybe to help you. If there's no solution, then you have to think of other ways. So as we mentioned, the axis of symmetry always goes through the vertex. And so I'm going to give you a formula for how to find the axis of symmetry. And that is x equals negative b over 2a. So remember, our equation of our axis of symmetry was x equals. And so this is actually the formula when you think about standard form, ax squared plus bx plus c. This formula comes from the standard form. So we're going to find the axis of symmetry of this example. So a in this example is 2, b is 4, and c is 5. So I'm going to plug this in. X equals negative 4 over 2 times 2. Which is negative 4 over 4, which is negative 1. So the axis of symmetry here is x equals -1. Now we also have to find the vertex. The vertex is the maximum or the minimum, we know that. But remember, the axis of symmetry goes through the vertex. So if you look back up here, the axis of symmetry goes through this point. So what is this point? This point is 2, -3. What is this point right here? This point is 4, 0. Notice that the x value of the vertex is the same as the x value in the axis of symmetry. So in order to find the vertex, you might want to write this down. In order to find the vertex, you're going to plug in the x value of the axis of symmetry to the function to find y. So here's what I mean by that. So f of x equals, I'm going to plug in a -1 for x, and that is going to give me the y value at that point, which is going to be the vertex. Make sure you do this correctly. -1 squared is 1. So this is 2 times 1. 4 times -1 is -4, and then plus 5. 2 minus 4, 2 times 1 is 2, minus 4 is -2, plus 5 is 3. So the vertex then, again, has the x value just like the axis of symmetry, so that's -1, and we just plugged it in to find y, which is 3. So that would be your vertex. So you can use the axis of symmetry to find the vertex and vice versa. If you know the vertex, if I know this is the vertex, then I automatically know that my axis of symmetry is x equals -1. So, just real quick, if I know my vertex is 3, -2, then I know my axis of symmetry is x equals 3, because it's going to be the line that goes through the x value of the vertex, because that's what a vertical line does. So 3 things here: solutions, vertex, and axis of symmetry. Be familiar with them. Make sure you understand how to apply them in problem situations.
I've been waiting way too long.